Welcome everyone, this is Ahmed Shukri, Ruijie Sales Engineer. Today we are going to introduce one of the most powerful and important security features used in enterprise networks. In this video, we will talk about 802.1X Authentication and how to add a strong security layer to your network by integrating three: a Redis server implemented by Microsoft NPS, Active Directory, and Dynamic VLAN assignment. This solution is widely used in professional and enterprise environments where security, identity, and access control are critical. So, what is this video series about? When the user's device sees the Wi-Fi broadcasted from the Ruijie access point and tries to connect, the access point immediately requests 802.1X authentication and asks the user to enter a username and password. Once the user enters his credentials, the Ruijie access point, acting as 802.1X authenticator, forward the authentication request to the NPS Redis server. The NPS server then communicates with the Active Directory to verify whether the username and password are valid or not. If Active Directory confirms that the credentials are correct, it sends the result back to the NPS server. At this point, the NPS server performs authorization. Based on the configured network policies, it decides whether the user is allowed to access the network and which VLAN should be assigned to this user. This is where Dynamic VLAN assignment takes place. The NPS server sends an access accept response to the Ruijie access point, including the VLAN attributes. Finally, the Ruijie access point enforces the decision, places the client into the assigned VLAN, and allows the device to access the network and the internet. In 802.1X, authentication and authorization are handled by the Redis server, while the access point only enforces the policy. In this series, we will cover two different product levels. First one, Ruijie Enterprise devices. Second one, Ruijie devices for SMB and SME environments. For this reason, we decided to divide this topic into two separate videos. Video 1, which will be this video, will be about 802.1X integration on Ruijie Enterprise access points using CLI configuration. Video 2, the link in the description below, will be about 802.1X integration on Ruijie access points using Cloud and GUI eWeb configuration. We will use the Ruijie Enterprise Access Point model AP880-L, and step by step we will explain how to prepare Active Directory, how to configure Microsoft NPS, how to configure the Enterprise Access Point, and finally, how everything integrates together to achieve successful 802.1X authentication with Dynamic VLAN. Some of you may ask an important question. Why do we start with Enterprise command line, while Ruijie access point can be configured easily from eWeb or the cloud and give us the same behavior? The answer is very simple. We start with Enterprise command line because it shows us the full picture and we will clearly understand how the Redis server is contacted, how authentication and accounting work, and how Dynamic VLAN assignment is decided. Once this foundation is clear, moving to Ruijie Cloud or eWeb becomes very easy. And more importantly, you will know exactly how to troubleshoot if something goes wrong. After that, in the next video, we will go to Ruijie access point and see how the same behavior is delivered in much simpler way. Before we move to the access point configuration, we need to prepare the identity and policy side of the solution. In this part, I'll show you how to create users in Active Directory, how to organize users in security groups, and how to use Microsoft NPS to apply different network policies, including Dynamic VLAN assignment based on user groups. Let's start with Active Directory. First, I'll create security groups in Active Directory. These groups will represent different access levels in the network. Example for that, I'll create 4 groups for testing my dynamic VLAN. Wi-Fi VLAN 1, 10, 20, and 30. Later, these groups will be used by NPS to decide which VLAN should be assigned to each user. On the Server Manager, Tools, select Active Directory users and computers. Right-click on shukri.local. New group. Group name Wi-Fi-VLAN 1. Group scope will be global. Group type will be security. Click OK. Repeat for VLAN 10, 20, and 30. Now I'll create 4 users in Active Directory. Each user will be added to a specific security group, depending on the VLAN or access level we want to assign. Right-click on shukri.local, new user. User login name will be Ahmad. Last name 1. Login name will be Ahmad1. Click next. Set a password. Confirm it. You can uncheck user must change password. Click next. Finish. I repeat the process for the other users. And here I add each user to the appropriate security group. This membership is the key element that NPS will use during authorization. Double-click Wi-Fi-VLAN 1, go to Members, click Add User Ahmad1, check Names, click OK, OK, Apply, and then OK. If you want to check it, double-click again. Go to Members. Finally, I'll repeat the same process with the other users. Now that Active Directory is ready, we can move to the Network Policy Server. In NPS, we will define who is allowed to access the network and which VLAN should be assigned based on Active Directory group membership. Let's move to the NPS configuration. Now we register NPS in Active Directory. This allows NPS to read user and group information. We will open NPS console. Open Server Manager, go to Tools, click Network Policy Server. In the left panel, right-click on NPS Local. Click Register Server in Active Directory. This is where you will add it on your system, but it is dimmed here because I have already added it before. Now that NPS is registered in Active Directory, we can add the Ruijie access point as a radius client. Next, I add the Ruijie access point as a radius client. Move to Radius Clients and Servers, right-click, Radius Clients, New, friendly name we can make it the name of the access point, 880-L. IP address of the access point, 192.168.110.15. Shared secret, then confirm it. Now we create network policies. In the Network Policy Server, go to Policies, Network Policies, right-click New. Policy name Wi-Fi-VLAN 1. Leave the type of the network access server unspecified. Click Next, adding the condition, which is our user group. Click Add, choose User Groups, click Add Groups, type Wi-Fi-VLAN 1, then click Check Names, OK, OK, click Next, select Access Granted, click Next, related to authentication method, click Add, choose Microsoft EAP, PEEP, click OK, Next, Next. I can add the dynamic VLAN attributes from here, or I'll finish it and reconfigure just to show you in case you want to change the authorization for specific groups later. So just press Next, Finish. Here we add the dynamic VLAN attributes. Double click on Wi-Fi-VLAN 1, go to Settings, add only these three attributes. Scroll down, tunnel type, click Add, value virtual LANs, VLAN, commonly used for 802.1X. Press OK. Then tunnel medium type, click Add, value 802, click OK. Last one, tunnel PVT group ID. Value 1, which is our VLAN ID. And remember, numbers only, no text. Click OK, close, apply, OK. I repeat the process for the others. Policy order is very important. NPS evaluates policies from top to bottom. Now that Active Directory users and groups are ready and NPS policies are configured, we can move to the Ruijie Enterprise access point and apply the 802.1x configuration using CLI. We will explain why we configure this, not just what we type in. We will start with AAA new model, then AAA accounting updates, then AAA accounting update periodic 1. First, we enable the AAA new model. This is a mandatory for any 802.1x radius or centralized authentication process. Then we enable accounting updates, and we configure periodic accounting updates every 1 minute. This allows the radius server to continuously receive session updates. Second command line group will be about radius server group definition. We will start with AAA group server. It will be about radius, and the name we can make it like Shukri_server. Then we will add the IP, server 192.168.110.200. Here I created a radius server group named Shukri_server. This group will logically represent my authentication backend, which is in this case Microsoft NPS. Inside the group, I define the radius server IP address. Now with the third part, radius server parameters, authentication, and accounting. I'll start with radius-server host 192.168.110.200 key Ruijie at 123. Second command line, radius-server host 192.168.110.200, authentication port 1812, accounting port 1813, and the key Ruijie at 123. Now I define the radius server globally. I specify the authentication port 1812 and the accounting port 1813, and I configure the shared secret key. This key must exactly match the key configured on the NPS side, otherwise authentication will fail. And now we move to radius reliability settings. We start our command line with radius dash server timeout 5 radius retransmit 3. These commands control radius reliability. The timeout is set to 5 seconds and the retransmit value is set to 3 attempts. This ensures stable authentication without long delays or false failures. Now with the AAA method lists, authentication and account binding. We start with AAA accounting network. We will name it Shukri_accounting. Then start stop group. We will use our radius server Shukri_server. Second command line AAA authentication .1x. We will name it Shukri_authentication. We will bind it to the group Shukri_server, which is our radius server. Now I create the AAA method lists. Shukri accounting is my accounting profile, which will send start and stop records to the radius server. Shukri_authentication is my authentication profile, which will be used specifically for 802.1x authentication. Both are bound to the radius server group. Here I will create all VLANs that may be assigned dynamically by the radius server. Start by VLAN 1, VLAN 10, VLAN 20, VLAN 30, and now I will create VLAN group 120, VLAN-group 120. This VLAN group will contain all VLAN that the radius server is allowed to assign dynamically. So the VLAN list will be 1, 10, 20, and 30. The default VLAN will be VLAN 1, which will be used before authentication complete. And finally, we will go to the VLAN assign mode. VLAN assign mode. We need to set it to .1x, meaning VLANs are assigned based on radius attributes. Now is the turn to configure the trunk interface. We will start with the physical interface. Interface G0/2 encapsulation .1Q group 120 IP DHCP snooping trust. Now we made the DHCP snooping is trusted here because this interface leads to the DHCP server or the trusted switching infrastructure. Now is the turn to configure the sub-interface to bind the VLAN group 120 to the trunk. Interface Giga Ethernet 0/2.120 encapsulation.1Q. Then enable the IPDHCP snooping trust. IPDHCP snooping trust. It allows all VLANs inside the group to pass dynamically based on 802.1x authentication. Now I'll create WLAN ID 1 with SSID name radius. So we add the command line .11 WLAN 1 SSID radius. The SSID should be linked to the VLAN group 120. So we add the command line VLAN-group 120, enabling dynamic VLAN assignment. Now the WLAN is also associated with WLAN security profile 1. So we add this command line WLAN security 1. Now is the time to configure radio interface binding. Now we will start with the 2.4 GHz band. Interface .11 radio 1/0.1. No encapsulation. Encapsulation.1Q group 120. Then bind it to WLAN ID 1 and also bind it to the security profile 1 WLAN. And now to configure the 5 GHz band. Interface .11 radio 2/0.1. No encapsulation. Then encapsulation again .1Q group 120. Bind it to WLAN ID 1 and also bind it to security profile 1. Now is the turn to the final important and critical part, binding WLAN security with 802.1x. So we start our configuration command line with WLAN sec1. The common command line is security RSN enable. Security RSN enable. Here we enable WPA2 Enterprise Security. The common command line is security RSN ciphers AES enable. And here we enable the AES encryption. And the final command line here will be security rsn AKM 802.1X enable. Here we enable the authentication key management to set to the 802.1X. Finally, I bind the WLAN security profile to the AAA method lists. First command line will be .1x authentication shukri_authentication. We already configured before. Second command line is .1x accounting shukri_accounting. At this point, the access point fully relies on the Radius server for user authentication and VLAN assignment. Now the enterprise access point is fully configured for 802.1x authentication with Dynamic VLAN assignment using Radius and NPS. Now that we have completed all the configurations, it's time to validate the setup from three perspectives: network devices, Ruijie Cloud, and the authentication server. This will show us clearly how 802.1x authentication and Dynamic VLAN assignment work in real time. Before testing, I first verify the VLAN configuration to ensure the network is properly prepared. On the switch, we can identify the ports connected to the Radius access point and the uplink to the Ruijie gateway. Next, we verify the VLAN configuration on the switch ports. As shown, all required ports are configured as trunk ports, allowing the VLANs to pass correctly. Now we check the VLANs on the switch to confirm that all required VLANs are created and active. After that, we move to the gateway to verify the VLAN configuration and ensure consistency across the entire network. Now that the infrastructure is validated, it's time to start testing from the client side. I'll begin by connecting using user account that belongs to VLAN 1. The device is now successfully connected. And from the client sections on the Ruijie Cloud, we can confirm that the client is correctly assigned to VLAN 1. I repeat the same process with other user accounts assigned to different VLANs to demonstrate Dynamic VLAN assignment based on user authentication. This confirms that the authentication, authorization, and VLAN assignment are working correctly across Active Directory, NPS, Ruijie Access Point, and the Ruijie Cloud. Here in the NPS event viewer, we can see successful authentication events for Ahmed 1, Ahmed 10, Ahmed 20, and Ahmed 30, each user matching the correct network policy and VLAN assignment. This was a complete 802.1x deployment using Ruijie Enterprise Access Point, Active Directory, and NPS. From design to live verification. See you in the next video.